In episode 30 of the CySec101 training series, we're going through the web application basics, and this is a part of the web hacking module that we have just begun. And the web hacking module is a part of the Cybersecurity 101 training series, or the Cybersecurity 101 pathway of TryHackMe. And as a part of this module, we are going through web application basics, JavaScript essentials, SQL fundamentals, Burp Suite, and of course, OWASP top 10. So this is going to be a strong module, and we're going to learn a lot about hacking web applications and websites, so on and so forth. So I'm really excited about going into this one with you. As always, we have our intro. This is actually a pretty long course, or this specific video I think is going to be pretty in-depth. So we do have the introduction, we have web application overview, uniform resource locator, HTTP messages, HTTP requests, which is the request line and the methods, and then we go into the headers and body, status line and status codes, and then again headers and body, but these are for the response. So we have the requests and then we have the responses, and then from there we have security headers, and then we have a practical exercise as well, and then we're going to go through the conclusion, and we are going to wrap it up and you'll be dismissed. This is a free room inside of TryHackMe, so anybody, as long as you just have a basic free subscription to TryHackMe, you can access this room. You can access the exercise for the practical task and everything else as well. So I do encourage you to try it out if you haven't done so already. If you don't have a TryHackMe subscription, I encourage you to get it. It's absolutely for free. All you need is an email and a password, and then if you want to go get the paid account as well, there's a discount link in the description below that you can use to get a discount off of your monthly purchase price. So that is it for our introduction to our web application basics video. If you'd like to support the channel, consider joining Hackaholics Anonymous, the premier YouTube community for security professionals and hackers. We have 4 tiers: the supporter, agent, guardian, and master. And each tier gets their own Discord server and early access to content, but the agent, guardian, master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And you can join by simply clicking the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the web application basics room. All right, here we go. So in this room, we're going to walk through the key elements of a web application, like the URL itself, the HTTP requests and responses. And if you're starting and you want to get a handle of the essentials, or if you're just looking to build or work with web applications, this is a great room for you, because we're looking at web applications from the context of cybersecurity, right? So by completing this room, you're going to understand what a web application is and how it runs in a web browser, breaking down the components of a URL and seeing how it actually helps access web resources, learning how HTTP requests and responses work, getting familiar with the different types of HTTP request methods, understanding what different HTTP response codes actually mean, and checking out HTTP headers and how they work and why they matter for security. And that's basically it for the breakdown of the introduction of this video. So let's jump into the overview of the web application. All right, so here's an analogy. We always start these things with a little analogy or story. So imagine there's a web application as a planet, right? So consider that the web application is a planet. Astronauts traveled to the planet to explore its surface, similar to how someone uses a web browser to explore or browse a web application. Although we only see the surface of a planet, a lot is going on under the surface. So you can imagine that the whole planet as a web server with many things going on under the surface of the web server, yet all we can usually see is the surface of the web pages or the application. We will now explore the various components that make up a web application. There's something called the front end, and it can be considered similar to the surface of the planet, the parts that an astronaut can see and interact with based on the laws of nature. A web application would have a user interact with it and use a number of technologies like HTML, CSS, and JavaScript to be able to do that interaction. HTML stands for the Hypertext Markup Language, and it's a foundational aspect of web applications. It's basically the most basic element of a web application is HTML. HTML. It's a set of instructions or code that instructs a web browser on what to display and how to display it, and it could be compared to simple organisms living on the planet. And they have DNA, which is the instructions for how simple organisms are put together. CSS, also known as the Cascading Style Sheet, in web application describes the standard appearance, such as certain colors, types of text, and layouts. Continuing the analogy with DNA, these could be compared to the parts of the DNA that describe the color, shape, size, and texture of the simple organism. And if you pay attention to the images on the left right here, you can see how the image gets a little bit more sophisticated with each layer of code, right? So HTML is literally the skeleton of the whole thing. It's the basic structure. And then CSS style sheets is where the coloring of the font comes in, and the various font styles, and the background color, and the menu shape and size, and so on and so forth. And then we have JS for JavaScript. And this is the part of the application on the front end that enables more complex activity in the web browser. So HTML can be considered a simple set of instructions on what to display. JavaScript is more advanced set of instructions that allows choices and decisions to be made on what to display. So in the planet analogy, JavaScript can be considered the brain of an advanced organism, which allows decisions to be made based on what and how something interacts with it. So JavaScript is more advanced interaction instructions and mechanisms versus HTML, which is, again, more like the skeleton, like the bare bones, the chassis of the website. JavaScript is where the interaction comes in, and you can have advanced interactions. For example, animated menus, as an example, falls under JavaScript. Then you have the back end. So the back end of the application is things that you don't see within a browser, but they're important for the web application to actually function. On a planet, these are the non-visual things, the structures that keep a building standing, the air, the gravity that keeps feet on the ground. A database is where information can be stored, modified, and retrieved. A web application may want to store and retrieve information about a visitor's preferences on what to show or not to show, and this would all be stored inside of the database. A planet may have more advanced inhabitants who store information about locations in maps, write notes in a diary, or put books in a library and files in a filing cabinet. There are many other infrastructure components underpinning the web application, like the web server, the application server, storage, various networking devices, and other software that support the web application. On a planet, these are roads that are present, the cars that run on the roads, the fuel that powers the cars, so on and so forth. And then you have the web application firewall, which is an optional component for web applications, and it helps filter out dangerous requests away from the web server and provides an element of protection. This could be considered similar to how a planet's atmosphere can protect inhabitants from harmful UV rays. That potentially could be the web application firewall. I don't know how I feel about this analogy of using a planet to kind of describe a web application, but it is what it is. I'm not the one who designed this course. So in summary, there are many components involved in delivering a web application. There's front-end components like the HTML, CSS, and JavaScript, which focuses on the experience inside the browser. And then you have the back-end components like the web server, database, and the web application firewall that are the engine under the surface that enable the web application to function. This simple introduction will be built upon in the upcoming tasks as we go further and further into this overall concept of a web application. So the first question is, which component on a computer is responsible for hosting and delivering content for web applications? So it's hosting and delivering content. That would be the web server. Which tool is used to access and interact with web applications? And that would be your web browser. And which component acts as a protective layer filtering incoming traffic? That would be the web application firewall. And do we have any more questions? We do not. Okay, great. So let's go into the Uniform Resource Locator. The Uniform Resource Locator, you know this more as the URL. I bet you didn't know that's what that actually stood for. So the Uniform Resource Locator is the URL. And it's the web address that lets you access all kinds of online content, whether it's a web page, a video, a photo, or other media. It guides your browser to the right place on the internet. Now, the anatomy of a URL is also something that's very interesting, especially when we're looking at this from the context of cybersecurity. So HTTP is known as the scheme. So it could be HTTP, HTTPS, so on and so forth. If you actually have a website that's been broken down like this, so if you have a URL that actually inside of the URL has the user and password as the parameters here, that it no longer exists where you can actually visibly see it, but maybe in the back end is something like, for example, on the URL that we see right here that I have, it just says TryHackMe room web applications. Maybe the back end URL is actually, it has my username and password inside of it. We just don't get to see it because it's protected, right? So we have the user : password that serves as the user, and then we have and then we have tryhackme.com being the host or the domain. And then we have port 80 right here, which ends up being the port number, and that's typically associated with HTTP for web servers or web applications. And then the path itself is where it starts after that port 80 / right here. So we see view room, and then this is the path, and then usually it has a query after the fact that, again, we don't see inside of our basic or inside of our URL that's up here, because it's a much more sanitized URL that doesn't view these things. But anything that starts after the question mark is essentially where the query begins. And so it says ID = 1. And then this piece right here, that's the hashtag that we see right here. This is more for, I would say, descriptor and identifier than for functionality. But it can be for functionality. So usually when you see hashtag task3 inside of the URL, and then you send this whole URL to somebody, when they press enter, it skips the page. So instead of landing at the very, very top of the page, it'll skip and it'll bring them to task 3. So that hashtag task 3 actually brings them to this fragment of the web page that is task 3. A lot of times it is a descriptor, but in a lot of cases as well, it actually has the functionality of bringing you to a specific part of the page. So this is the anatomy of a URL, especially, assuming that it actually has the user and the path and the query string and so on and so forth inside of it. So if you think of it as being made up of several paths, each playing a different role in helping you find the right resource, understanding how these parts fit together is important for browsing the web. So let's actually go into the details that they give us for everything that you just saw inside of that image. So it starts with the scheme, which is that HTTP part. It's the protocol that's used to access the website. The most common is HTTP or HTTPS, which is the secure version of the hypertext transfer protocol. HTTP is more secure because it encrypts the connection, which is why browsers and cybersecurity experts recommend it. Websites often enforce HTTPS for added protection, and usually if you visit a website that does not have HTTPS, your web browser will say, this is insecure, are you sure you want to continue? And then you actually have to manually say, click on something. It's usually like advanced options or something. There's like a link on that, and then when you click on advanced options, it says proceed to website. Then we have the user. So some URLs can include a user's login details, usually a username for sites that require authentication. This happens mostly in URLs that need credentials to access certain resources. However, it's rare nowadays because putting login details in the URL is not safe, not even very safe. It's literally not safe at all to do that. It can expose sensitive information, which is a security risk. And then we have the host or the domain, which is the most important part of the URL. So that would be the Google in google.com. And then it's basically the website that you're actually accessing. So every domain name has to be unique and is registered through domain registrars. From a security standpoint, looking for domain names that appear almost like real ones but have small differences, this is called typo squatting. These fake domains are often used in phishing attacks to trick people into giving up sensitive information. So, for example, Google could be Goog and then the number 1 and then E, and then that would be .com. Same thing for like Gmail or something like that. Or there's, the alphabet of various other languages can actually be also used to purchase a domain name. And so somebody could pick a character that looks just like the letter L, but it's actually not the letter L. It could be a different letter from a different language, but when you look at the domain, it looks like it's Google, and that's actually very, it's more of like an advanced version of domain name registration. And when I learned about that, I was like, wow, my mind didn't even stretch that far. I didn't even realize that you can actually do that. But then as soon as somebody tells you, you're like, oh, that totally makes sense. There's other languages that have characters that look like the letter L or something like that. And it's like, oh, of course that you could do that and put that inside of a domain name. So the port number helps to direct your browser to the right service on the web server. It's like telling the server which doorway to use for communication. Port numbers range from 1 to 65,535, but the most common are 80 for HTTP and 443 for HTTPS. And these are default, and if you really want to make sure that you protect your web server and you don't want people to find you by default ports, then you can always just change your web server ports, and sometimes 8080 could be used for a web server, or 8000 could be used for a web server, as long as it's not the default port 80. The path points to the specific file or page on the server that you're trying to access. It's like a roadmap that shows the browser where to go. Websites need to secure these paths to make sure that only authorized user can access sensitive resources. And then you have the query string, and it's a part of the URL that starts with a question mark. It's often used for things like search terms or form inputs. Since users can modify these query strings, it's important to handle them securely to prevent attacks like injections, where malicious code could be added to the URL and then it can do some kind of an injection directly into the web server. We also call that a server-side request forgery. And then we have the fragment, which starts with a hash symbol and helps to point to a specific section of the web page, like jumping directly to a particular heading or a table. And you can modify this too, like with query strings. It's important to check and clean up any data here to avoid issues like injection attacks. So, which protocol provides encrypted communication to ensure secure data transmission? That would be HTTPS. What term describes the practice of registering domain names that are misspelled variations of popular websites? And that would be typo squatting. And then what do we have? We have what part of a URL is used to pass additional information, such as search terms or form inputs, to the web server. And that was the query string. I believe that's it. So let's see if that's actually the answer. Query string. Very good. And that's it. So let's jump into HTTP messages. HTTP messages are the packets of data that are exchanged between a user, also known as the client, and the web server. So when you see the client error, that means that it's something on your end. When you see a server error, it means something on the web server's end, right? On the hosting provider, so on and so forth. These messages are important for understanding how web applications work because they show how users request and the server's responses are communicated. So the user makes requests and a server responds. Imagine an example of an HTTP request and an HTTP response where you can see key parts like the method URL headers and status codes. These are what make the client-server interaction possible. So the HTTP request is sent by the user or the client to trigger actions on the web application. And then we have the responses that are sent by the server in response to the user or to the client's request. And so this is what this looks like. We got to make a little bit zoom in right here. So this is what the HTTP request looks like, where we're making a post request to get the login page. And the post request is when we send data, meaning our username and password, for example, and we're sending it to the login page on TryHackMe. So it would be tryhackme.com/login, basically. And then the username would be Alexandra, and then the password would be secure password. And that's the data that's being sent via a post request to that web server. And then the web server responds with a 200 status code, which is the perfect status code if you've done everything correctly. And then as a response, it says login successful, success, and that's basically it. So this is what a response code or a response looks like from the web server, and this is what our request looks like to the web server. So each message follows a specific format that helps both user and server communicate smoothly. So the start line is like the introduction of the message. It tells you what kind of message is being sent, whether it's a request from the user or a response from the server. This line also gives important details about how the message should be handled. So that is the very, very first line that we see right here, which is the post, login, or the HTTP 101 200. Okay, that part, that's the start line. The headers are made up of key value pairs that provide extra information about the HTTP message. They give instructions to both the client and the server handling the request or the response. These headers cover all sorts of things like security, content types, and more, making sure everything goes smoothly in the communication. Then there's an empty line. And it's a literal divider that separates the header from the body. It's essential because it shows where the headers stop and where the actual content of the message begins. Without this empty line, the message might get messed up and the client or server could misinterpret it, causing errors. Then you have the body, which is where the actual data is stored. In a request, the body might include data that the user wants to send to the server, like form data, for example, Alexandra's username and the password. That was part of the body. In a response, it's where the server puts the content that the user requested, like a web page or API data, or basically just saying login successful. That all falls inside the body as well. So why understanding these things matters is these messages are the foundation of web application communication. If they're structured properly, everything works smoothly. Knowing how they work will help you diagnose issues in web communication, which means better performance and reliability. It's also really, really good for security and pen testing and hacking if you know how these things work and how to potentially manipulate them. Understanding HTTP messages helps you implement strong security measures to protect data during transmission or to manipulate web page requests. Which HTTP message is returned by the web server after processing a client's request, and that would be the response. And we have what follows the header in an HTTP message. That would be the body, right? So what follows the header is the empty line. Empty line, that's what it is. So we have an empty line, and that's basically it. So now let's look at the HTTP request, request line and methods. The request is what a user sends to a web server to interact with the web application and make something happen. Since these requests are often the first point of contact between the user and the web server, knowing how they work is very important, especially if you're into cybersecurity. And this is an example of a request. So we have the get method. So this is our HTTP method. You can have a get method, a post method, a put method, a delete method. There's a few different HTTP methods that can go inside of a request. And then this is the path that we want. So in this case, we want to get this specific page, which is the login page. And then this is the version of HTTP for this specific web application, right? And then these are the headers where the host would be TryHackMe. So it would be tryhackme.com/user/login.html. That's the page that we are getting with our request. The user agent is Mozilla, so probably Firefox or something. It accepts this. The accepting of the language would be English, US, and then we have connection to keep it alive so that you don't have to retry multiple times, and it just keeps that connection alive until you either close your web page or log out, something like that. So imagine an HTTP request showing the key parts of the key parts like the method, which is get or post, the path itself, which is the login version of the HTTP. These elements make up the basics of how a client or the user communicates with a web server. The request line or the start line, the very first line, is the first part of the HTTP request and tells the server what kind of request it's dealing with. And it has three main parts: the HTTP method, the URL path, and the HTTP version. So we have the method, which was either get or post, anything like that. You have the URL path, and then you have HTTP version. And a lot of times it could just be a / as the path because you're just trying to land on the home page. That's basically it. The HTTP methods come in a variety of shapes and sizes. They tell the server what action the user wants to perform on the resource identified by the URL path, and these are some of the most common. We have the get method that's used to fetch data from a server without making any changes. Make sure you're only exposing data that the user is allowed to see. So avoid putting sensitive information like tokens or passwords in GET requests, since they can show up as plain text, and that's very, very important. The POST method sends data to the server, usually to create or update something, and always validate and clean the input to avoid attacks like SQL injection or cross-site scripting. The PUT method replaces or updates something to the server, and again, make sure that the user is authorized to make changes to the server before accepting the request. This could be something like, updating your profile picture on your Facebook page or something like that. That could technically be an update, or updating your bio. That could technically be an update. So something that already has some kind of a value, and now you're changing or updating that value. That's all done with a PUT request. The delete is just like the name implies, it removes something from the server. So just like with PUT, make sure that only authorized users can actually do this. And besides these, there are a few other ones that are used in specific cases, and these are not as common. So we have the patch method, which updates parts of a resource and is useful for making small changes without replacing the whole thing, but always validate the data to avoid inconsistencies. We have the head method, which works like GET, but only retrieves the headers, not the full content. It's handy for checking metadata without downloading the full response. And then we have options, which tells you what methods are available for a specific resource, helping clients understand what they can do with the server. And then we have trace, similar to options. It shows which methods are allowed, often debugging. Many servers disable it for security reasons, because it shows you what is actually allowed on the web server, and a lot of times that could give enough information to a hacker for them to start doing some shady stuff. The connect is used to create a secure connection like HTTPS. It's not as common, but it's critical for encrypted communication. Each of these methods has its own set of security rules. For example, patch requests should be validated to avoid inconsistencies, and options in trace should be turned off if not needed to avoid possible security risks. And then you have the URL path. So the URL path tells the server where to find the resource that the user is asking for. So in the URL here, tryhackme.com API users 123, the path is basically after.com. So it's anything after.com. That's the path that we are trying to retrieve, which is the API user 123, and it identifies a specific user on that API, right? So attackers often try to manipulate the URL path to exploit vulnerabilities, so it's crucial to validate the URL path to prevent unauthorized access, sanitize the path to avoid injection attacks, and protect sensitive data by conducting privacy and risk assessments. And this was something that happened as recently as 2024 with Microsoft Outlook, and that was the moniker link video that we did maybe like 3 or 4 episodes ago, 5 episodes ago, and it was the very first episode for the exploitation portion of the CySec101 series that we were in, and that vulnerability was literally in 2024, and it was on Microsoft Outlook, and it was based on the modification of the URL. So the attackers learned how to, essentially what they did was they would put an exclamation mark inside of the URL, and they were able to manipulate the URL so that if somebody clicks on it, they automatically capture the credentials of that user just by the user clicking on the link, which was insane. And it wasn't just an exclamation mark, it was like an exclamation mark, and then after the exclamation, they had the actual exploit inside of the URL. But that was basically a perfect example of what we were talking about here, where they manipulate the URL to exploit vulnerabilities. So the HTTP version shows the protocol version used to communicate between the client and the server, and the rundown of HTTP versions, the most common ones. We had the 0.09 that was in 1991, which is the first version, only supported GET requests. And then you had 1.0, which is in 1996, 1.1 in 1997. The 1.0 added headers and better support for different types of content, improving caching. 1.1 brought persistent connections, chunked transfer encoding, and better caching. It's still widely used today, and that was from 1997. We have HTTP 2 from 2015, which introduced features like multiplexing, header compression, and prioritization for faster performance. And HTTP 3, which was from 2022, built on HTTP 2, but uses a new protocol, which is QUIC, for quicker and more secure connections. And so although HTTP 2 and 3 offer better speed and security, many systems still use 1.1 because it's well supported and works with most existing setups. However, upgrading to 2 or 3 can provide significant performance and security improvements as more systems adopt them. Now, which HTTP protocol version became widely adopted and remains the most commonly used version? And that was HTTP/1.1. And which HTTP request method describes the communication options for the target source, allowing clients to determine which methods are supported by the server? And I think that was options, right? Yeah, that is options. And in a request, which component specifies the specific resource or endpoint on the web server that the client is requesting, typically appearing after the domain? And that would be the URL path. And that's it. So now let's go to headers and body. Request headers allow extra information to be conveyed to the web server about the request, and these are some of the common headers. So the host specifies the name of the web server that the request is for. So for example, tryhackme.com. The user agent shares information about the web browser that the request is coming from, and Mozilla 5.0 is most likely Firefox. The referrer indicates the URL from which the request came from. So it could be coming from google.com, for example. Cookies are information the web server previously asked the web browser to store, and it's held inside of its cookies. So usually, if you have your cookies stored, it makes sure that you don't have to re-log in again, or it reloads your session from where you last left off, so you can kind of pick up where you left off, so to speak. The content type describes what type or format of data is in the request. And of course, these are just the examples that we see right here. The request body, so in requests like post and put, where the data is being sent to the web server, as opposed to requests from the web server, the data is located inside the request body. The formatting of the data can take many formats, but some common ones, are URL encoded form data, JSON, or XML. And the URL encoded, which is application X, this is essentially what you see inside of the body, is a format where the data is structured in pairs of key and value, key value pairs, basically, where you have a key equals value. This is basically what the syntax looks like. Multiple pairs are separated by an AND symbol, such as key 1, value 1, and key 2, value 2. Special characters are percent encoded, so you don't actually see the character. You do see some kind of a URL encoded version of the character. And so this would be an example right here where we see the key value pairs. So you see application URL encoded, and then we see name equals Alexandra, so that's one key value pair, and then age equals 27 and country equals US. So there's 3 key value pairs. We have form data, which is a multi-part part form or form data technically, and this is basically what we see here. Technically, this is technically form data, I believe, because it looks like it's a form that was URL encoded, right? So form data allows multiple data blocks to be sent, where each block is separated by a boundary string. The boundary string is the defined header of the request itself. This type of formatting can be used to send binary data, such as when uploading files or images to a web server. So this is what this kind of looks like. So we have a WebKit form boundary, and so the content would be form data, name, username. That's what we're sending. And then we have Alexandra, and then the content disposition is the profile pic, file name Alexandra JPG, and then we have the binary data that's also going with it. And then this is the end of the form boundary, or excuse me, this is the for the binary data. This is the other form boundary. But you can see right here, right? So for the form data username being Alexandra, let's say, we have Alexandra's username that is being submitted with this other form boundary right here that we see here. Or I think, you know what? My bad. So based on what it says over here, the boundary string is defined header of the request. So this is where the header is, and then everything inside of this, including this right here. That's all this portion. And then we have this and as another boundary. So everything inside of that right here would be for this boundary. And then that includes the profile pic and Alexandra JPG, so on and so forth. And then we have another one at the bottom, supposedly. So it's all separated by the WebKit form boundary portion, where this is all one part, and then anything between these things is basically another section. In this format, in the JSON format, the data can be sent using the JavaScript object notion structure, and data is formatted in pairs of name value where they're separated by the colon. Multiple pairs are separated by commas, all contained within curly braces or curly brackets. So this is what we see. This is the beginning bracket or brace, and then that's the closing brace. And then so we have name equals Alexandra, age equals 27, country equals US, and this is JSON encoding or JSON formatting. And then we have XML formatting, which is structured inside labels and tags, which have opening and closing, and these labels can be nested within each other. You can see in the example below opening and closing of the tags. So the opening would be this, for example, you have user, and then the closing has that /, and this is how you can tell that there is a closing tag. And for the name, there's also a closing tag. For the age, there's a closing tag. The country has a closing tag. Essentially in XML, anything that has an opening tag has to have also a closing tag. Otherwise, the code breaks and it doesn't work. And XML is kind of like the more advanced version of HTML, but HTML looks just like this as well. HTML has an opening tag and a closing tag, and they work inside of these little greater than, less than symbols right here. And this is basically what it looks like. So essentially the same data, right? Just different formatting. So which HTTP request header specifies the domain name of the web server to which the request is being sent? And that would be the host. What is the default content type for form submissions in an HTTP request where the data is encoded as key value pairs in a query string format? So it's the one where we have key value pairs in a query string format, and that was the one up here, I want to say. Key value pairs, query string format. I don't think that's the one. It should be right here, key value pairs. So this is the application XForm encoded portion. So we're going to go do that. And then we're going to just bring this and paste that here. And which part of an HTTP request contains additional information like host, user, agent, and content type guiding how the web server should process the request? And that is also over here. So let's go, and I want to say it's form data, right? Boundary, no, this is not form data. The URL encoded, where the no, request body, right? Are posted where data is set to the web server. The formatting of the header can make forms. I think it is the request body, right? Or is it the request header? So hold on. Can allow information to be conveyed about the request. Some comments are, maybe it is the header. I feel like it's the header. It's either the header or the body. It's one of the, it's one or the other. But I think it's the header. So let's see, request header. Is that right? That is right. Okay, great. Perfect. All right, cool. It was a 50-50 chance that it was either going to work or it was going to fail, and then we would end up with request body, one of those two. But so that's the part of the request that contains additional information like the host, the user agent, and content type guiding how the web server should okay, I see. Yes. That is indeed the request header. Okay, very good. Now let's talk about responses. So these are the responses coming from the web server. So what we see here are a couple of response codes, right? So 200 is, as the check mark implies, it's a good one. And then 500 and 404 are some kind of error response. So when you interact with a web application, the server sends back an HTTP response to let you know whether your request was successful or something went wrong. These responses include a status code and a short explanation called the reason phrase that gives insight as to how the server handled your request. So the status line, which is the first line in every HTTP response code, is called the status line. And it gives you three pieces of info: the HTTP version, which tells you which version of HTTP is being used; the status code, which is a 3-digit number showing the outcome of your request; and then the reason phrase, which is the message explaining the status code in human readable terms, if just in case you don't know, you haven't memorized the status code, right? So Since we already covered the HTTP version in task 5, let's focus on the status codes and the reason phrases. The status code is the number that tells you if the request succeeded or failed, while the reason phrase explains what happened. They fall into 5 main categories. You have informational responses that are in the 100 range. So it goes from 100 to 199. And these mean that the server had received part of the request and is waiting for the rest and its keep going signal. That's basically what it is. So anything inside the 100 range is basically a keep going signal. The success range is in the 200 range, so from 200 to 299, and it could mean everything worked as expected, and it could be, as long as it has something that starts with a 2, you can most likely get access, or you've already gotten access, and that's basically what the response code for a successful request is, right? So it could be anything that ranges that means that you're good, right? The server processed the request and sent back the requested data. And then you have the redirection message that is inside of the 300 range, 300 to 399. And they tell you that the resource that you requested has moved to a different location, usually providing the new URL of the location, because it means that it's accessible still to you at your user level. It's just the location has changed. Then there's the 400 to 499. Usually a 404 error is what most of us see. And these indicate a problem with the request. So maybe the URL is wrong, or you're missing some required information like the authentication or something like that. But typically, you most likely, if you have been online for any length of time, at the very least, you've most likely ran across some kind of a 404 error where you tried to access a page that was no longer there, like the URL is broken or something like that. So you see a URL error, a 404 error. And then you have the 500 range, which is a server error. So the 400 range is a client error. So this is on your end, right? Like you did something wrong as the client. The 500 range is a server error. And this means that the server encountered an error while trying to fulfill your request, and they're usually server-side issues and not your fault, meaning the website has to fix something on their end. So the most common status codes that you'll run across would be the 100 to continue. So the server got the first part of the request and is ready for the rest of it. 200 is an okay, meaning it was successful and the server is sending back the requested resource. 301 is moved permanently. So you're requesting something that's been permanently moved to a new URL, and the new URL from now on, you got to use that. 404 is not found, so the server couldn't find the resource that was given. Double check that you've got the right address or the right URL. And 500 is an internal server error. Something went wrong on the server end and it couldn't process the request that you made. So which part of the HTTP response provides the HTTP version status code and a brief explanation of the response's outcome? And it's the first line. So it's the status code, or actually it should be the, it is the status code, right? So status line. So status line, it gives you 3 things: the code and the reason and the phrase. So that would be the status line is the information. Which category of HTTP response code indicate that the web server encountered an internal issue or is unable to fulfill? And that's the 500 series. So the internal server error is that part. And so we'll just copy and paste that right there. Whoops. Come on. Oh, really? It says that the web server encountered an internal issue or is unable to fulfill the client's request. That it is an internal server error. Or maybe 500 is specifically the internal server error. So it could be server error responses. That's probably what the answer is that we're supposed to do. There we go. Which HTTP status code indicates that the requested resource could not be found on the web server? And that would be 404. And boom. All right, so we're good. So now we can move to HTTP response headers and body. When a server responds to a request, it includes the HTTP response headers, which are basically key value pairs. And these headers provide important information about the response and then tell the client, which is the browser, the web browser, your browser, how to handle the response. So picture an example of an HTTP response with the headers highlighted. This is the picture right here. Key headers like content type, content length, and date give us important details about the response of these servers. So we have This is the first line, the status line, right? So HTTP 1.1 status is 200, okay, so we got a good response here. We have the content type, which is the application JSON, content length, the date and time of this thing, the message, login successful, and status, which was success. And then you can see that this is JSON format because of those little squigglies. And then the way that it's been outlined, we have the key value pair separated by colons and a comma right here. So that is a response example. So required response headers. These are crucial for making sure that the HTTP response actually works properly, and they provide essential info that both the client and server need to process everything correctly. So we have a couple of important ones right here. So you have the date, for example. This header shows the exact date and time where the response was generated by the server. You have the content type, text HTML, for example. It tells the client what kind of content it's getting, whether it's HTML, JSON, or something else. It also includes the character set like UTF-8 to help the browser display it properly. And then we have the server, which is Nginx in this example, and it shows what kind of server software is handling the request. It's good for debugging, but it can also reveal server information that might be useful for attackers. So many people remove or obscure this specific value, which is a very good idea, because if it is Nginx, especially if it gives you the version of Nginx server that's running, that's also really, really good information that you can use to kind of manipulate your requests and responses. So the other common request headers that we have are the set cookie. So setting your cookie for your session ID. This sends cookie from the server to the client, which the client then stores and sends back with future requests. And to keep things secure, make sure that cookies are set with HTTP only flag so they can't be accessed by JavaScript, and the secure flag, which is only for HTTPS. You have the cache control. This tells the client how long it can cache the response before checking with the server again, and it can also prevent sensitive info from being cached if needed using the no cache. And then you have the location, so index.html, for example, being the home page. That's typically what the home page's path is. If it's not just a /, it's index.html that is reserved for the home page. And it's used in redirection, which is the 300 response codes. It tells the client where to go next if the resource has moved. If users can modify this header during requests, be careful to validate and sanitize it. Otherwise, you could end up with open redirect vulnerabilities where attackers can redirect users to harmful sites. Then you have the body of the response. And this is where the actual data lives, things like HTML, JSON images that the server sends back to the client to prevent injection attacks like cross-site scripting. It's always good to sanitize and escape any data, especially user-generated content, before including it in the response. And the question we have here is, which HTTP response header can reveal information about the web server's software and version, potentially exposing it to security risks if not removed? And that is actually our server right here, this thing right here. So we can do just a basic server, and that would be our answer. Which flag should be added to cookies in the set cookie HTTP response header to ensure that they're only transmitted over HTTPS, protecting them from being exposed during encryption, which is not no cache, it is HTTP only. It's this one right here. And there we go. Oh, really? I see. So protecting them from being exposed during unencrypted transmissions. I thought that was it. So it says response to ensure that they are only transmitted over HTTPS. And I thought that was it. So, oh, secure flag. Secure flag. Secure. That's the answer. There we go. Which flag should be added to cookies in the set cookie HTTP response header to prevent them from being accessed via JavaScript, thereby enhancing security against, I'm going to say is it no cache? No, let's see. The set cookie is to prevent them from being accessed via JavaScript. So prevent them from being accessed via JavaScript. Let's see. That one is the HTTP only. That is the code. Sweet. All right, so let's talk about security headers. Security headers help improve the overall security of the web application by providing mitigations against attacks like XSS, cross-site scripting, clickjacking, and others, and we'll now dig deeper into these specific headers. So you have the content security policy, you have the strict transport security, X content type options, and referrer policy. You can use a site like securityheaders.io to analyze the security headers of any website. After the discussion of this task, you will hopefully have a better understanding of what it is actually reporting on. And let's just visit that site real quick just so we can see what it does. So we have, security headers. So let's do tryhackme.com and let's see what the analysis of that is. And, what do we got? So we got strict transport security, content security policy, X-frame options, X-content, referrer policy, permission policy. These are all the headers that actually do exist. You should work on your security posture immediately, is what it says. Maybe they're trying to sell us something. These are the missing headers, it seems, where it says strict transport. All these things seem to be missing from TryHackMe. And then we have our raw headers that are available here. That's so funny that that's like what's missing. Although I feel like it's not missing. I feel like maybe just as the base domain, maybe that's what's it doesn't have it because it's just a basic domain without people logging in or something like that. That would be so funny. I mean, if anybody from TryHackMe is watching this, then you have a good review from securityheaders.io. So CSP, Content Security Policy, is an additional security layer that can help mitigate against common attacks like cross-site scripting. Malicious code could be hosted on a separate website or domain and then injected into the vulnerable website. A CSP provides a way for administrators to say what domains or sources are considered safe and provides a layer of mitigation to such attacks. Within the header itself, you may see properties like the default source or script source, defined, and many more. Each of these give an option to the administrator to define at various levels of granularity what domains are allowed for what type of content. The use of self is a special word or special keyword that reflects the same domain on which the website is hosted. So the use of self is very interesting. So looking at an example CSP, we have content security policy, default source, self. I see script source, self. And in HTTPS TryHackMe, style source, self. So this is a special keyword that reflects the same domain on which the website is hosted. Interesting. We can see default source, which specifies the default policy of self, which means only the current website. Script source, which defines the policy where the script can be loaded from, which itself is along with the scripts hosted on TryHackMe. And then we have style source, which specifies the policy for which the CSS style sheets can be loaded from the current website itself. Strict transport security, also known as HSTS, ensures that the web browsers will always connect over HTTPS. So if we look at this, we have strict transport security. Max age is 600. I think this is in seconds right here. It includes subdomains and preloaded. So max age is the expiry time in seconds for this setting. Include subdomain, an optional setting that instructs the browser to also apply settings to all the subdomains. And preload is an optional setting that allows the website to be included in preload lists. Browsers can preload lists to enforce HSTS before even having their first visit to a website. X content type options can be used to instruct browsers not to guess the MIME type of a resource, but only to content type header. This is an example where you say no sniff. So no sniff is the directive that instructs the browser not to sniff or guess the MIME type. And the MIME type, just to kind of get the breakdown here, it's the multi-purpose internet mail extension, which is an internet standard that extends the format of email messages to support text in character sets other than ASCII, as well as attachments of audio, video, images, and application programs. So you don't want it to guess the MIME type, which is the standard that extends the format of email messages. So the referrer policy controls the amount of information sent to the destination web server when a user is redirected from the source web server, such as when they click a hyperlink. So the header is available to allow a web administrator to control what information is shared. And there are some examples of the refer policy. So when you land on somebody's blog and you click on a link and you leave their blog, this is the policy that determines how much of your information from the first blog is being sent to that website that you just clicked on through the hyperlink. So refer policy, no refer, same origin, strict origin when cross origin. So no refer completely disables any information being sent about the referrer. Same origin, this policy will only send refer information when the destination is part of the same origin. This is helpful when you want to refer information past when hyperlinks are clicked within the same website but not outside for external websites. Strict origin only sends the refer as the origin when the protocol stays the same. So a refer is sent when an HTTPS connection goes to another HTTPS connection. And then strict origin when cross origin is similar to strict origin except for same origin request where it sends the full URL path in the origin's header. So this is all about the referrer policy. Now, in a content security policy configuration, which property can be set to define where scripts can be loaded from? So we're going to go to our content referrer policy, and it says where scripts can be loaded from. And this would be specifies the type of self, which means the only current website. So default source, I would say. So default source, script source is where the script can be loaded from. So I would say script source is probably the one. So let's try that. Very good. When configuring the strict transport security header to ensure that all subdomains of a site also use HTTPS, which directive should be included to apply the security policy to both the main domain and its subdomains? And this one is going to, where is it? Include subdomains right here. That's the one that we want to use. And then we got which HTTP header directive is used to prevent browsers from interpreting files as a different MIME than what is specified to the web server, thereby mitigating the content. And that was the one that we had right here, which is no sniff. We don't want you to try to sniff or try to guess what we're doing. We want it to be discovered. Okay, very cool. Now, the practical task, here we go. I got to zoom out on this so that we can actually view this website. All right, for this practical exercise, we're going to use an emulator for making demo HTTP requests, and using what we've learned, we're going to answer the questions that we have below. So let's visit this site here, and we have it right here. So it says, would you like to take a guided tour to learn more about how to get started? I'm going to skip that. And then hopefully that doesn't come and bite me in the butt later. Okay, so it says make a GET request to API users. What is the flag? So we are going to change this right here. And then we're going to just change. Let me see if I can actually modify this here. Maybe I should have GET request. TryHackMe. Let me see. Update the parameter. Enter the value. I feel like I should have actually paid attention. No, you know what? So we're going to, I think I just need, yeah, there you go. That's what I need to do. Boom. I know what I'm doing. Let's go. And then go. And here we go. And so we got that. And where's my flag, which is right here. So THM, you have just found the user list. Boom, boom, and boom. So all I had to do was just change the domain right here. The path, which is API users, that's where we're trying to go. And we now have access to the user list. Look at that. Alice, Bob, Charlie, and what else do we have? Their countries and their ages. And that's all we got. All right, so make a post request to HPI user 2 and update the country of Bob from UK to US. So we're going to change this up here to post, and then we're going to update the country of Bob to HPA users 2. So there's that. And then let's see if I can make a post request. So right here, it's going to be country, I believe. And then the value is going to be US. And I'm going to save that and proceed. And then we're going to go. It says cannot find page. So what's the hint? It says Watch out for case sensitivity. I see. So let's try this one more time. So I am making a post request, and it's going to API user 2, and we're updating the country of Bob. So maybe I just need to change the country from a uppercase to a lowercase. So let's delete this one more time, and then we'll do country lowercase, and the value is going to be US, and then save that, proceed, go. Okay, that is one important thing that I did not do. I was doing users 2, and it should be user 2. And then here we can go ahead and make this modification real quick one more time. I think that was a really big key right here. So we'll close that one more time, and then we'll do country, and we'll do US. And let's save that, proceed, and then run that. There we go. User 2 successfully updated. And okay, so now what? So it says make the request and update the country of Bob from UK to US. What is the flag? I mean, I made the request, so where's my flag? Got it. Okay, so the country actually had to be a lowercase c instead of an uppercase c. And that's our flag. So just to show you what the value was, it is a lowercase c in country, and then US was the same. And that is our response right there. So we're going to submit that. That's what they meant when they said case sensitivity. And now make a delete request to API user 1 to delete the user. So that should be fine. We're going to do delete user, and then we're going to do user 1. Let's see. We're going to delete this right here as well, and make sure that that's all good. Okay, good. So we're deleting user 1. Go ahead, and that's it. So that one was easy money. And there we go. We were able to finish all of those responses. So not hard to do, really. This was fairly simple. So we just sent a delete request on the last one. We sent a post request on this one, and it was user 2. And we just changed the parameters right here. And we added a lowercase country, and then US was the capital case value. And then the very first one was just a get request to our users list that we were able to do, and we were able to retrieve all the users, and that is the way cookie crumbles. So we are officially done. So let's see what the conclusion says here. The conclusion basically says that we completed all the tasks. Hope you enjoy learning about the elements of an HTTP web application. So I hope you enjoyed learning about it as well. And I hope you learned a lot. I hope it was one of those things that it was kind of eye-opening. I know that it was like more of a lecture, and there wasn't as much practical stuff that we did, with the exception of those like few little exercises at the end over there, compared to what we did in the last 2 or 3 videos when we were using Metasploit to do an exploit and then hacking to a Windows machine. Like, compared to all of that, this seemed like a walk in the park. So hopefully you still had fun with it, though. Hopefully you still learned something, and you were able to walk away with a new introduction to a very important concept, because pretty much everything is now being hosted either on a web application or a web server or something like that. So if you understand the basics of HTTP methods and requests and responses and all of that stuff, then you have the exact foundation to go into some of the more advanced stuff as we go into Junior Pentester and Pentest Plus and so on and so forth. So I hope you got a lot of value out of it. And yeah, let's wrap it up. If you did get any value from this video, I do encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out, especially in the CySec101 series, as we it seems like we've gotten to the second half of it, and we're approaching kind of like the end of the CySec101 series. And there is a massive playlist that's already on CySec101, and that is actually in our playlists that are available over here. So definitely check it out if you have not checked it out already. And drop a comment if you have any questions as we go through this. If you just want to say hi, so on and so forth. I am very responsive in the comment section, so I do respond to everybody's comments as they come in. And if you have really good questions, I'll respond to them them in a video format or very similar to what we're doing here in a playlist format so that you can get all of your questions answered. So make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out, especially in the CySec101 training series, and of course in everything else that's available on the channel as well. And then drop a comment, make sure you say hi or ask your questions, even if you just want to say thanks. And a great way to say thanks would be to support this channel by joining Hackaholics Anonymous, the premier community for security professionals and hackers. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content, but the agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. I hope I see you in the Discord servers. If not, I hope I see you in the comment section, and that's it. This is your boy Hank Hackerson at Hank Hacks Hackers. If you have a network and system attacker/protector, if no one else loves you, Hank loves you. Love, peace, and chicken grease, and I'll see you in the next video. Later.